Okay, what I'd like to do is go to Desmos, look at each of the different formulas, let's explain what we think is going to go on, and let's have Desmos actually make the graph for us. The first thing you want to see is that in a little folder here, I put the formula for the graph. Now, it doesn't really matter what the formula of the graph is. We should be able to do this with any weekly graph. But you can see the way you do this with Desmos is in parentheses, you put an inequality chain, and then a colon, and then a formula, then a comma, then another set of inequalities, then a colon, then a formula, and it'll graph the whole thing all at once, so it really is treating it like one function. Now I'm just going to close the folder so we don't have to stare at the formula. I would like the graph back so we can see how things are going to compare. Now that is the graph of f of x. The first thing we were asked to look at was the graph of f of x plus 1. Well, let's put a little note here. Since the y values here are higher than the original function, this next formula should just move the whole graph up 1. Now let's go turn on the graph just to make sure that it's actually what happens. And sure enough, in green, you can see that the whole graph just got moved up 1 because we just added 1 to the expression. Not so bad. I'm going to turn that graph off and look at the next expression. Now this graph, because the x minus 1 is on the inside, only moves the function to the right or to the left. There's lots of different ways of explaining it. The one that most people are usually comfortable with is if it's x minus 1, what you're going to do is move it 1, but you move it to the opposite direction that you think you should. The reason for this, we'll try to explain this in class. But meanwhile, I think that graph should actually be the original graph, move 1 to the right. So let's add a little note. Adding a note. This next graph, I'm telling you, I clicked on note. And let's move that down here, actually. Right there. Let's do this. Good. This next graph should be what we get when we move the original 1 to the right. Now let's just turn on the graph and make sure that's exactly what happened. And sure enough, you can see in purple, you get our new graph. That's the original moved 1 to the right. Yay. So let's just shut that one off again. Let's actually bring down our note for the next one. Looking at the next graph, now again, the minus x is on the inside of the graph, so we know actually what's going to happen is a horizontal change. Now, if we look down a little bit, minus f of x, we know what that one does. That feels very comfortable. That takes whatever's on the top and moves to the bottom, and whatever's on the bottom moves to the right. The f of minus x is a horizontal change in a very similar way. It takes whatever's on the right-hand side and flips it to the left, takes whatever's on the left-hand side and flips it to the right. So let's enter that as a little note here. This next graph should be what we get when we flip the right side to the left and the left side to the right. And I'm just going to check that to make sure it works. And sure enough, that's exactly what you get. Instead of having a spike on the left-hand side, we have now a spike on the right-hand side. The circle, when we flip it, it's symmetrical with respect to the y-axis, so it doesn't change at all. But we can see that this little valley over here that used to be in brown is now this little valley way over here, which is now in black. So it did what we thought it was going to do. The next one we've already described. I would like to add a note there. I'm sure it'll actually let me add the note there, so let's just see. No, it didn't. Let's move it down to here. Adding a note. The next graph should be what we get when we flip the top to the bottom and the bottom to the top. In other words, this half circle on top should be now on bottom. This valley should turn into a spike on top. This little plateau should actually be flipped to the top. And when we turn that part of the graph on, sure enough, that's exactly what we see. Let's change the color a little bit so we can see that in a different color. And you can see that the original graph now has a mirror reflection. Right? Instead of this valley on bottom, we have a little mountain on top. Instead of this little hill on top, we now have a hill on bottom. Instead of this little valley on the bottom, we now have a blue plateau on top. So that pretty much did what we thought it was going to do. Good. Finally, we have f of 2x. I would like to add a note there. I tried to add the notes up down there where I want them, but it won't go. Let's go down to here. Now, this 2x is on the inside, so it's only going to affect what's going on sideways. It shouldn't affect the heights. But usually, I think our natural inclination is to say it stretches it by a factor of 2. But it doesn't really stretch the graph by a factor of 2. It stretches the axis by a factor of 2, horizontal axis, and then leaves the graph alone. What it makes the graph then look like is that the graph goes up and down twice as fast, which means the whole thing is going to get squished by a factor of 2 closer to the y-axis. Let's write that down. This next graph, this final graph, should be what we get when we squish the whole graph toward the y-axis by a factor of 2. Now let's just put a little note. What we're really doing is leaving the graph alone and stretching the x-axis by a factor of 2. Regardless of how we describe it, what we should see is something that goes down and up twice as fast, then has a smaller circle here, and then comes down twice as fast and doesn't go nearly as long. So here we go, clicking on it, make sure I get the graph, and you can see that's exactly what happened, right? Instead of this nicely coming down and going up, I go down and up real fast. The circle gets squished by a factor of 2. It's only half as wide. And this little valley over here is also only half as wide. So we were right about the 2x being a squishing or stretching, but it absolutely is a stretching.